Who got distracted?
What was the goal of this activity?
What was the goal of the activity? What did you guys do, Sam?
Find an average of that big ass paragraph.
You found the average word length, right? I'm going to abbreviate, but I put it into school appropriate terms.
Why? Average
Word length. And what did we do to help us accomplish that goal? What did I have you guys do?
Find 5 samples.
5 samples of what size?
5.
5 samples of 5 words. So, some semi-new words, terminology. Statistic is a number that is computed from a sample. A parameter is a number that is computed from a population. And the way I keep that straight is the first letter. So statistic starts with an S, so does sample. Parameter starts with a P, so does population. We've seen the notation for both samples and population when we're working with means. With a sample, we use X bar to mean mean. When we're working with populations, we're going to use mu. They both mean mean, but now this tells us that our mean came from a sample. This tells us our mean came from the population. We're also going to start focusing on proportions. So when we're working with a proportion and it comes from a sample, we use p hat. When we find our proportion from the population, it's just p. You always use a statistic to estimate a parameter. Somebody want to read the paragraph below the number line for me? Thanks, Nate. I knew I could count on you.
In the warm-up, we took a smattering of different samples of 5 words. There are many, many possible SRSs of size 5 from a population of size 268. If we took every one of those possible samples, calculated the sample proportion for each.
Sorry, hold on. I should have said average there.
Okay.
Go ahead.
Calculated the sample average for each and graphed all those values, we would have a sampling distribution.
Thank you, sir. So, sampling distribution, here's our definition. It's the distribution of values taken by the statistic in all possible samples of the same size from the same population. And I put an asterisk next to it because I can promise one of your multiple choice questions on the Unit 7 test will be about what a sampling distribution is. The biggest part is it comes from taking all the possible samples the same size from the same population. If you only look at some of the samples of that size, you don't have a true sampling distribution. Can I move it up? All right, so when a statistic consistently overestimates or underestimates, I'm going to start over. When a statistic consistently overestimates or underestimates a parameter, we say that Anybody remember the word for overestimating or underestimating? Chapter 4. Started with, she's like, I hated that chapter. Me too, it's my least favorite chapter. Starts with a B, ends with an S, bias. Bias is where you consistently overestimate or underestimate. And bias usually happens because you have a poor sampling method. So, in the warm-up, the Gettysburg Address activity, I purposely used a poor sampling method so that we would have bias. So what could we do to remove bias from that activity? Carter talked about it. He asked me, what was your first question about how to do it?
Use a random word generator.
Well, not word generator, number generator. I mean, I suppose never mind. That's semantics. I'm not going to get into it. So we're going to use a random number generator so that you guys get random samples of size 5. Not Hayden over there who said he got a sample with all the, what did you call them, special words? Fancy words. Because they had an average of 7.8. He said he got it randomly, but I don't know. So we're going to use our random number generator. Anybody remember how to, oops, I forgot the word random. Well, table D is, but your calculator has it. Anybody remember how to get there? You do?
I think so.
What is it?
Random. Mass probability random.
Yep, thank you. So we're going to use a random number generator to get a true SRS. Because even though I did see some of you, like Cheyenne, she was looking at me and she went like this. And then she stopped on a word. So she was trying to do it as random as possible. But now we're going to use our number generator to get a true SRS. And just because, well, it's been a while since we said SRS. What does that stand for again? You guys have listened to me throughout the year. Thank you. All right, and Nate told us, but I kind of glossed over it. So will you tell us one more time how to get to the random generator?
If you map over to prob down to random to 5 on mine.
Thank you, sir. So you hit math, go to prob, and then number 5. I'll let you have this one in a minute. And then the newer calculators prompt you, but if you're working with an older one, you want to put the smallest number, which is 1. And then our biggest number, which there are 268 words in the Gettysburg Address, and on the next page, they're in order numbered for you. So 1 to 268, and you want to take a sample of size 5. That one didn't have any repeat numbers. If you get a sample of size 5 that has a number twice, just redo it. And by the way, once you've done it once, you can just go back up there and highlight and hit enter so that you don't have to redo it every time. Okay? The older ones, either just like exact for my older ones, do not scroll up once you have it. Like if you can't read them all, don't go up or down.
Well, I thought it was,
It'll get angry and freeze on you.
I was like giving these numbers to possible and I'm good. Just find the biggest word of the day.
I numbered the words for you, so 151.
Oh, then you pick some of those.
151 is right there. Here.
I thought that was a pickup line.
Like, what kind of word Yes. Oh, you have an extra band in front of it. That's why I give you that. Problem is like it shouldn't be integers or whole numbers. 268, comma, 5. And then don't scroll up. See how it's got the arrow? If you like your initial please for me is go up and then scroll. But just scroll there. Okay?
I have an answer. Okay, wait, how do you get there again?
Math. Go over to problem. Number 5. Did you go up to it? You can't. Once you highlight it, it freezes. So that. You see how it has the arrow? Don't go up to it. It's annoying. Yeah, so you can't read the previous one.
What do American numbers look like?
No, that's cheese.
All right.
What's the American numbers?
Once you have your 5 numbers, 5 averages, we're going to make a second dot plot. I was going to have you copy the warm-up and make this one really small, but we're going to make it big too. That did not work. I wanted to connect those. You need to have 5 samples, 5 words again, so 5 averages that you're going to come put up here on our dot plot. Again, do your best to estimate because I can't cover every single decimal. Right. So once you have your 5 averages this time around, come make another dot plot for us, please.
times the run is fair.
Why is it white?
Because originally I was gonna have us make it small and put the sketch of the warm up right next to it, but I figure I can put it back and forth.
What's the copy down now?
Yep, when you have your 500, just go up there. Put your dots on the dot.
Oh shit, I forgot which one it's mine.
Nobody else wants to put dots up there? Come on. We need more dots. We need more dots. Remember when they used to make that ice cream out of the little dots?
Dippin' Dots. I love Dippin' Dots.
Why not just eat normal ice cream?
Just didn't know.
They're different,
You
Mrs.
don't
Whittle.
buy Dippin' Dots at a store. You get them at like a place. You know, you're at
I
like a
know.
fair or whatever. You don't buy it.
It's special.
And that's like,
So you're one of those people who is all about the experience?
kind of, it's like, I don't go places, but when I do, I want it to be different from my normal life. Wi-Fi's not an option.
I don't like cones. They're nasty. I like ice cream.
Never had Dippin' Dots?
Do they even like still sell them?
Yeah,
They
they're
are
the
the
long.
longest.
They have some long. They're expensive at the mall.
Yeah.
I agree with you. It's not worth it. taller.
And it falls from their
I
grace.
can take my own ice cream.
Yeah, you would.
Well, not freeze. That'd be so much work though.
I'm sure they've got some sort of like ice cube mold that's smaller, and you could get the ice cream kind of melty and put it in there and then
Let's put it on like.
Yes. Those were so good. Only
The cold like services.
Oh, for like when they roll ice cream.
like a
like a cold stone. Yeah. That all came from me wanting you guys to put more dots on a dot plot.
Yep.
Sometimes I worry about my train of thought.
Keep on having.
I got trying to
I got all over the place.
do.
I am too. Something
Me
bad.
and my humming too. I randomly hum. I was at my son's basketball game with my mom. Through the cheering, like it was so loud. She's like, "What song are you playing?" I'm like, "Oh, nothing. It's not a song. It's just my brain." What was cool?
So things with the
Like, oh, I didn't know that. Anybody else gotta put their dots up there? Did you put your dots up there this time, Tyler?
They were pretty much the same from
Yes, I think it was very nice.
That means you were pretty unbiased in yours.
Really don't like it. Why would you buy it?
Why did
They're
you
not
say-
good.
Oh my god, I forgot that.
Oh, good. Really? Whoa.
It's fun.
That's crazy.
What did you do, Maddie?
Is that the big stuff?
What did you do, Maddie? Anybody else? Last call for dots. All right. So we're gonna backtrack just slightly. I want you to flip back to the warm-up dot plot. How do we describe a distribution? What's our acronym? SOX. So we're gonna describe this. So S, what's the shape? What would you guys describe that shape as? Skewed right?
Skewed left.
I don't know that it's actually really skewed at all. It is pretty. Sorry. I'm in rare form today. I would say it's pretty symmetric because we have some odd stuff at either end, not a whole lot of like outliers only on one side. So I would say, what did you call it? Pretty unimodal? Pretty unimodal. Outliers is our O. I'm not going to actually find out if they're outliers, but 2 kind of sticks out from everything. These don't stick out too far, but they might be outliers. So I'm going to say possible high and low. Now the center. Ooh. How do we find the center on a dot plot?
You like count them all up.
Yeah, I think that's what you were saying, but I can't hear over his muffled movies over there. Gosh, every period. You were saying count them up, right, and find the center. Well, assuming you all put your dots up here, that's 2, 4, 6, 8, 10, 12, 14, 16, 17. Carter was here when we did the warm-up, right? 18 times 5, that'd be 50, 90. So we're looking for about, I don't care, nobody's going to get in trouble. Anybody not put the dots up here for the warm-up? 1, 2, 3.
Wait, no, I put
Not every, I think it's not each one.
For the warm-up. So 2, so 80. You didn't... All right, so we're looking at like 75-ish. So we're looking around 37. Because I don't want to count up how many dots we actually have. So 1, 2, 3, that's 7, 8, 11, 13, 15. I think that's 3, 18. 1, 2, 3, 4, 22, 23, 24, 25, 26, 27, 31, 32, 33, 34, 35, 36, 37. So somewhere here or here would be the center, assuming we have 75 dots. So around 5, right? And then the last S is spread. And our highest is 8, lowest is 2, so 8 minus 2 is 6. So our spread is 6. We're going to do the same thing for this new dot plot. What would you say about the shape? Really? I would say this one's got some skewness to the left. Calvin's samples, not to call you out, Calvin, but I saw you put the dots down here. Calvin's samples throw us off. Gosh, Calvin. It's okay. Skewed left. Slight skew left. Gotta throw our safety word in there. And since we have skewness to the left, we probably have some low outliers. And the center. All right, raise your hand if you can put dots up for this one. So I don't care if you did or didn't. Put your hands up if you came and put dots up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that 11? Oh, 13. Noah, you didn't put dots on this one?
Close.
Did you put dots on this dot plot?
Oh, yeah.
14. That's 70, right? 5 times 14, 70. So we're looking for about 35. 1, 2, 3, 4, 5, 6, 8, 9, 12, 13, 14, 15, 16, 22, 23, 24, 25, 26, 27, 32. So 35 and 36 would be about there, which would be about 4.4. It looks like that's where you guys are. And then last one, spread. So the highest here is 6, lowest is 1.9. So that's 4.1. Did I do my subtraction right? That's 4.1, right? All right. So a true SRS using the random digit generator eliminated the bias, some bias I should say, in the true sampling, in our sampling distribution. It didn't eliminate all, but it eliminated some. I think I told you back when we looked at the Gettysburg Address, I think it was chapter 4, the actual true average. Do you guys remember? It was 4 something. Anybody remember? No? It's 4.28. So when you guys got to pick the words, our center was around 5. When we did a true SRS, we got closer to the actual true mean. So the bias that got eliminated was that we didn't overestimate.
Can I get the stuff like I got this stuff?
Everything? Not right now. Come back at lunch. I can't fit estimating.
What's that noise? Who's playing?
It's Weinberg.
It's always one.
It's always Weinberg. And his, I'm assuming war movies, world studies.
Well,
Right.
playing.
Yesterday, during 7th grade, Maddie, this is why I went back there.
Yeah.
Whatever he was playing, it literally, the voice, because it was a guy narrating, it sounded like the guy that does the direct threat lockdown.
Oh.
And it was like the same monotone, and it was like just a pattern. The guy talked very much the same, and I literally, Maddie was back here working on her test, and I went to the wall and listened because I was like, is it playing somewhere else and not in every classroom? Like it kind of messed with me. She was like, what are you doing? I'm like, don't worry about it. All right, so by making it an SRS, because we used the random digit generator, we eliminated some bias, so we didn't overestimate quite as much. What could we do to make our sampling distribution even better? No thoughts? What about make your sample size bigger? Yeah, go with that one. So I had you guys do a sample size 5 because that's pretty attainable for you to do, especially in a class when I'm having you do 5 samples. But if we wanted to reduce our bias even more, we could do that by making our sample size bigger. The higher the sample size, it reduces our variability. So we did variability. I think I spelled that right. We did reduce our spread, because spread is how much variation you have in your distribution. It did get reduced somewhat. We went from 6 down to 4. But if we worked with bigger sample sizes, then it would take that spread and put it even closer together. Yes? So I think I touched on this at the end of the last unit. You want to try and make you don't want to take a sample that's bigger than 10% of your population, but that's a good, right around 10% is the best sample size you can take. So 10% of 268 would have been 26 words. And that's just too much to ask you guys to do. That's about like the guideline. You don't want to go over 10%, but you want to be right around it. Did I answer your question? Yeah. Okay. Any other questions? All right. So we're going to be focusing on statistics and sorry, in my head, like, I'm like, oh, we're going to focus on statistics. That's a statistics class. To estimate parameters. And there are 2 things that we want to look for to make sure that our statistic is a good estimator. The first one is that we have low bias. And I showed you today that we can reduce bias if we have a good sampling method like an SRS. The other thing we want is low variability. And we can reduce variability by increasing the sample size. So, I only gave you 3 homework problems tonight. Start you out nice and easy. And we're going to look at some examples of what they're going to look like down here. Sorry, I should have asked, were you guys good? Can I move it up? Usually I do, I forgot that time. Alright, so, they're good thing it's Friday. Underlined numbers in each of the problems below, and it's either a statistic or a parameter. So we're going to figure out which one is the statistic, which one's the parameter, and then we're going to use the proper notation. So remember I told you, sorry, I like to color code. Statistics, if it's a mean we use X bar, if it's a proportion it's P hat.
Like probability, like S.
The only time we've used hat before was in chapter 3 with Y hat, and it meant we were making a prediction. Which, if you think about it, you take a sample and you're saying this is the estimate of the population. It kind of is like a prediction. And then parameters, for mean it's mu, and for proportion it's just P. So those are the notations we got to get used to. So one says, on Tuesday, the bottles of Arizona iced tea filled in a plant were supposed to contain an average of 20 ounces of iced tea. Quality control inspectors sampled 50 bottles at random from the day's production. These bottles contained an average of 19.6 ounces of iced tea. So we have 2 underlined words, numbers 20 and 19.6. I personally find it easiest to identify the statistic, the one from the sample first, but that's just me. So 20 ounces or 19.6 ounces would be our X bar, our sample mean. Which one? 19.6, because up before that sentence it tells us they sampled 50 bottles and those bottles contained 19.6 ounces. So X bar is 19.6. That's our statistic. Which means the other one is our parameter. And we use mu for that. Any questions before we look at the next one? By the way, you don't have to put statistic in parameter. I just did that to hit home that we're distinguishing between the two right now. All right, number 2. On a New York to Denver flight, 8% of the 125 passengers were selected for random security screening before boarding. According to the Transportation Security Administration, 10% of passengers at this airport are chosen for random screening. Which one, 8% or 10%, do you guys think is our statistic?
8%.
Why?
It's talking about the flight.
Because it's talking about a specific flight. So that would be like a cluster sample. We have a flight that we would assume mirrors the population, and so we can use it as a cluster sample, and that would make 8% our statistic. 10% is our parameter because that's out of all the passengers that go through the airport, the population at the airport. Percents are proportions. So we're going to use p hat. And how do we write 8% as a decimal? Because proportions have to be written as decimals. Sorry. I asked and then I spoke over it. Cheyenne? 0.08. Thank you. If you don't remember, just divide by 100. Move your decimal 2 to the left. And that means 10% is our parameter. And we use P for that one. And 10% is a decimal. 0.1. Any questions? No? All right.
Basically, the statistic is just the narrowed down.
And there's the bigger one. Are you here for a license?
Yeah.
Can I finish my thought?
Yeah, where